Hi guys, so we'll be building a staking dApp on the CrossFi blockchain, and we'll be staking MPX tokens and NXFi tokens. Okay, these tokens are actually ERC20 tokens, not the actual native tokens. Okay, so let me just connect to the wallet and let's see the interface how it looks like. Okay, yep, and yeah, we've connected. So yeah, we have our dashboard here with the token balances and the reward this user have earned so far. So he has earned 0.00003. How many zeros there? Okay, so we have um where you can stake. So this is where you stake. You can stake maybe 1,000 tokens, then determine the duration you want to stake for. Then, yep, that's the lock period, right? So click this and you stake. Okay, so but we're not testing now. We'll test after we built everything. So yeah, and we have this also. We have our stakes. So all the stakes this particular user have done. So it's all here, and we have two lock stakes and uh one completed stake, which was withdrawn already. So okay, yeah, let's get to work. Hi guys, so we'll be starting with Mix IDE. So the first thing I'm going to do here is to start create a workspace. We'll be using a template, the basic templates. Yeah, so just to have a setup ready for us. And yeah, this is it. So we'll be creating three four files, which is the first one will be stake, and the next one will be x5, and the third one will be npx. So yeah, and the last one IRC20. Yeah, so this stake file, this is what we put in our actual staking contract. The xfi is the token contract for the xfi token, ERC20 xfi token want to create. Then the mpx also for the ERC20 mpx token want to create. Then this is the interface in which our stake contract will be interacting with our tokens. Okay, so let's get started with the mpx. Okay, so we'll be starting with pragma solidity. We're starting with our solidity. So this is what we'll be having. Okay, and then um we'll have to import some open zeppelin contracts, which is we're having the ERC20 token, the burnable, and also the earnable. Then um another thing we'll be doing is to now let me paste the contract itself here. So I'll just explain. All right. So yes, like I was saying, the MPX token, which is our staking token, is an ERC20 token. Also, the X5 token also will be an ERC20 token. I think we're done here. Yeah. So we added a function to mint, so we can help mint to any other user, any user that needs MPX. So yeah. All right. So moving to the X5 contract, it's pretty much the same with the MPX. So we just copy everything and we'll paste it here. Yep. Close please. All right. So um, the only thing we need to change here is the name and the symbol. So we're going to change it to X5, and we'll change this to X5. And yeah, we are done with both tokens. So we'll be moving to the interface. All right. So we're starting that one with yeah, our license. SPDS. I don't know how to spell that shit, so let me just copy it. Okay. All right. Okay. All right. Okay. So we say Pragma. Okay. So our compiler interface. IRC20. That's our interface name. So we'll start with the events. The first event will be the transfer event. So yeah, for those, let's go back to the MPX token. So okay, so if you don't know how the ERC20 token looks like, you can visit the Open Zeppelin contracts and you'll see how it looks like. So I just wanted to um, find that out. So yeah, let's continue. Okay, so address. Okay. Mhm. Index. By taking the address of the person sending and then the address of the person we're sending to. So okay, and then the amount you want to send. So the next event you'll be doing is the approval event. So events, the approval event, and that will be taking the address. That is the address of the person who is sending, the owner of the token, and the next one will be the person we are approving. So the spender, we call that the spender. Okay. Then yeah, the amount. All right. Oh, I have to. Oh my god, that's funny. Okay. Now the functions. We are done with the events we are going to be needing. So the function. The first function we're doing here will be uh the total supply. Hmm, total supply, which will be an external. Oh my god, what's going on today? External view and returns. 256. Okay. Then the next one will be the balance of function. Balance of this one will be taking address account. So I want to check which the balance of an account. External. And it will return you int 256. Okay. The next function will be the transfer. So yeah, these functions are just the ones we're going to be needing in our stake contract. Okay. So the ones we're going to be interacting with in our stake contract. Remember I said this interface is what we use to this interface is what we use to interact with the token contract from our stake contract. So yeah. Mm-hmm. So now return. Yeah. So this returns returns boolean. Okay. And next will be our allowance, which takes the owner and the spender. All right. Going to be external. Of course, everything in the interface is going to be external. View returns new int 256 function. The approve approve function, which will be taking the address of the spender, of spender, and the amount we'll be sending. Okay. External returns. It should be returning bool if approved. Okay. Cool. Yeah, I forgot to put the semicolon here. Okay. Now the transfer from function. It's going to take the address from and where the address is going to, then the value, that's the amount we are sending. Also external and returns bool. Mm, and that's a wrap for the token contract and its interface. So we're moving to our stake contract now. Okay, so let's move on to our stake dApp. Let me copy. Let me copy the compiler. Compiler. Yeah, you can actually delete this one. No more reading this. Okay. Then import dash slash IERC 20. Okay. And the next thing will be our contract. Okay. And yeah, these are our these are all the variables we'll be needing. Okay, so let me just explain each variable for you guys. We'll be storing our X5 contract here and the MPS contract here. So yeah, you can see it's a type of IRC. We're indicating the interface here that we're going to use to communicate with this from this contract. Okay, so then we have our owner, the owner of the contract, and yeah, the owner will be transferable here. So we have the locked, which is either true or false. So we're using this one to practically lock to determine if a stake is locked or not. All right. So the next one we'll be having our constants. These are our three constants. Okay. So the first constant here is determining the minimum stake amount. All right. While the second one here is determining the maximum stake amount. And this is the reward per second. There's a little calculation later we'll be doing to determine this reward per second. To determine a reward for a stake actually. So yeah, now this is the staking structure. So this is the structure of each stake from anybody. So we have the amount, the start time, the duration, and the withdrawn, if it has withdrawn or not. Okay, so I want to know if the staking is withdrawn or not. All right, and yeah, we have an array of staking which is being mapped using the staker's address. So we are keeping track of each stakes. We are keeping track of each staker's stakes so far in the contract, right? Then we have the total reward. We are keeping track of each staker, each user total reward. Okay. Okay. All right. And then yeah, in this place we have the constructor, and the constructor is practically for is like the one-time call when we are deploying, and we're just going to put in what's it called? We're just going to just going to take the parameters of our token contract addresses. So the XY contract and the MPX contract. Then we are going to set our owner. So we are setting our owner to message sender, which is the person that is deploying. Okay. So which account is deploying? That's the message sender. Okay. We have the events here. So we practically have three events so far. Throughout this, we'll be having the deposit. We'll be having the withdraw whenever there's a withdrawal. So and yeah, whenever there's a transfer of ownership. Then these are modifiers, the only owner. So this will be modifiers for functions which only owner are allowed to access. Okay. Then we have the retransfer guard. The retransfer guard is just just to avoid recording of call recording of the contract. Okay, when a transaction is in process. So I think that's all. Yeah. So we're moving to our first function. Okay, so function stick. So what are we going to be needing? We'll be needing our amount, we're needing the amount you want to stake. Then we'll be needing the duration. And that's no, then make that external. And we intrinsic guard. So we're calling the intrinsic guard on this. So yeah, correct. So I think like a sanity check to know if um there's actually an address. Okay, so zero address not allowed. All right. Let me just paste the remaining one. And here we have it. Okay. So, oh sorry, that's cool. Nice. So we're good to go. Um, we're going to first do like call the transfer from transfer from. So yeah, we're going to call the transfer from which will have the msg.sender, and yeah, so we're doing like a transfer from, which allows the contract to spend the stake contract to spend the MPX on behalf of the user. So that's just what we're doing here. Yeah. Okay. And so staking, I'm going to set the data now. So memory, secondary that amount will be equal to the amount passed. All right. Then staking entry dot duration will be equal to log dot timestamp. So we're getting the current time, then plus the amount of seconds given in the contract. Okay. So the current time plus the amount of seconds given by the user. All right. So we say plus duration, and I think that's it. Then we're also going to set our start time. So we're saying staking entry dot start time will be equal to, yeah. So it will be equal to the time the transaction was initiated. That's the block the timestamp. Yeah. So I think that's all for what you are saving to the data. Okay. Now we're going to uh, save that into the contract. So msg dot sender dot push. We're pushing this into the stakes. All right. So into the stakes in which is mapped for the particular user. So we're pushing it into that array. So staking entry, and that's it. After that, we emit our event. So we emit our events. So the staker will be msg dot sender. That's the person sending initiating the transaction. Then the amount will be, yeah, the amount obviously, and we'll be passing the timestamp here too. So we say block dot timestamp. Yeah, so that's the for the stake function. All right. So moving on to the withdraw function. Okay, function withdraw stake. We'll be passing index. So you int 8. Okay, underscore index, which will be external. We on the reentrancy. Then it will be return bool for us, a boolean value for us. So we're expecting a withdraw successful or not. So that will be boolean. So before that, before we continue the withdraw stake, we'll have to do the calculation of the reward. So we just have a function that will undo that. So all right, we just have a function that will do that. So calculate reward doing 256. So yeah, we're going to be passing the start time, and we're going to be passing. We're also going to be passing the end time here. So this will be a private function because we're only calling it within the contract. So okay, and this returns an integer for us because yeah, the number, the amount the amount we are supposed to reward the user. So in 256, and that's it. Yeah. So we're going to be calculating the duration of the stake, and that will be equal to our end time minus our start time. Okay, so this is just like the period, we're calculating the period at which the stake took place. So we'll be returning the stake duration multiply stake duration multiplied by the reward per second. So these are the reward is being calculated. So how many seconds in between the end time and the start time, then multiplied by the reward per second. That's just it. And if you remember, we specified the reward per second up here. So this is the reward per second. And yeah, so let's move on. Please remember, everything we're putting in this contract is already in way. You understand? So later in the UI, the front end, we'll be converting everything to ethers. So okay, so this like 0.0000001. Lots of zeros though before the one when it comes to ethers. So moving on, sorry. Moving on. Back to our withdraw stake. So I'm just going to paste the required stuffs for the withdraw stake. Just going to paste that. So yeah, like what you're saying, we're checking for we're doing a sanity check here. Then we're also checking if the the index that was passed, if there's a stake within that index. Okay, all right. So if there's a stake within that index for this particular user, then we're now saving. If there is, then we're now saving it inside this staking entry. So yeah, let's move on. And yeah, we're checking for the duration, what's it called? The time the stake is supposed to expire. So if it's not yet expired, so it's not yet time, then we're also checking if it's withdrawn or not. So yeah, now we'll say you're in 256 amount staked will be equal to staking entry dot amount. Okay, so you're in 256. Sorry. Oh my god. Okay, we go to calculate reward. Remember our calculate reward function, right? So yeah, I'll be saying staking entry dot start time, and yeah, we'll be saying staking entry dot duration. So we now have everything there. Now the total reward and the MSG to send that. So we're now adding this reward, the total reward end. No, we're not adding any reward that was calculated here to the total reward end by that particular user. So yeah, adding so so that's just okay. So it's just adding the reward calculated after a withdraw, and is adding it to the initial total rewards this part the user have earned. Okay, now we'll go to staking entry. So we have to close the stake. So staking entry dot as withdrawn will be equal to true. So we're closing the stake. Staking entry dot amount will not be equal to what? Zero. Oh my god. Staking entry dot start time will also be equal to zero. And the last one, which is the end time, which is the duration, sorry, will be equal to zero. So we're going to be transferring back the MPX token. That was no, not this. Yeah, so we're going to be transferring back the MPX token that was assigned to our contract to stake. So sorry, MSG dot sender, and the value will be what will be the amount staked. So yeah, then we're also going to be transferring the X5 token too that this person have earned. Yeah. So MSG dot sender, practically the same thing, right? Then yeah, we'll say reward amount. Yeah, we are good to go then. So we are going to emit the withdraw successful event, which will be taking the staker with the staker, the MSD, MSD dot sender. Then the amount, which will be amount staked, and yeah, the reward, which is reward amount. That's good. And then we return true. So it has the withdrawal is successful. That's after it's successful. Yeah. So we now have our staking. Now our staking function and the function to withdraw the stake when it's done. Then now we'll be moving on to other functions. Yes. So the next function is one which allows us to get an information about a particular stake. So we'll say function get staker info. Okay. So unit 8, of course, we're passing our index here, which will be external, and view, which also returns the staking. All right. So require MSG sender. So we're just going to check for the zero address. Let me just copy that from you. We're checking for the zero address. Okay. And also checking for uh the so I didn't put the same stuff here. Okay. We're checking if the contract is available. And I say the contract, sorry, the stake is available. All right. So now we'll say return stakers MSG sender index. Good. We are good to go. So the next one will be the get all stakes. So I want to get all the stakes by user function address. So external, and this returns our staking area also. So says staking. Oh shit, memory require. So we're also doing the zero address not allowed. So I'll just copy that. Then we have another one which will be giving us so I want to check if the staker have already staked initially. So stakers it should be greater than zero. But if it's not greater than zero, tell us stakes found. Alright. So return stickers sticker. Yeah. So I'm just using the sticker address to get using the sticker address to get a particular to get all the sticks the user have staked. Now we are going to uh function. So we're just going to get the contract balance for both tokens. So get Okay. Yeah, no parameters needed for this. So external only owner return. So this will just return the balance. So unit 256. Yeah, return. Yeah, sorry. Just contract dot balance of then account. Sorry, address this. So we're referring to this address. Hmm, what's going on? Hmm, okay, found what's happening. All right. So okay. I think the issue will be here. We okay. We forgot to add view. Yeah. So yeah, I think that'll be good to go. Yeah. Wow. Now then we can just duplicate this. Yeah. And we can say get x5. All right. Get contract x5 balance. So yeah, instead of the MPX contract, we say x5 contract. And yeah, we've done for both tokens. Now we're moving to the transfer ownership function. So function transfer ownership should be address. We're passing the new owner's address, which should be external, so we can call it. And only owner. Yeah, so only the owner of the contract can call this function. All right. And new owner. Sorry. First thing, we're going to be requiring that it's not a zero address calling the function. Then new owner. We just set the new owner variable to whatever this is. So we just set the new owner variable to whatever address was being passed. So and I think that's it for that. Then the next function is to claim ownership function. Claim ownership. Oh my god. Which will also be address. Oh sorry, no address. We're not passing anything here. So external. So I thinking. So we're going to need the zero address, the sanity check. Then we're also going to we're going to check if um this person's what's it called? Person's address, the person that's calling this, if the address is actually is actually the address actually the address specified in the new owner. So if it's not equal to address sorry, equal new owner. So if it's equal to the new owner, the message will be if it's not equal to the new owner, sorry. If it's not equal to the new owner, the message will be not your turn. And yeah, we have that right. So we're going to emit if all these checks are then we are going to emit ownership transferred. So previous owner will be owner and the new owner. So I think that's it. Then we say owner will be equal to new owner. Then we set the new owner to address zero. That means no address. Good. And we are good to go. So that's all about our contract. So we have our staking function which allows us to stake and which allows us to permit the stake contract to stake on behalf of us. And then we have the withdraw of stake that gives us the opportunity to withdraw our stake when the time, the duration is met. So, and we inside there we have the calculate reward function, which helps us to calculate our reward based on the duration. Okay. Then we have the get staker info and the get all stakes, which helps us to get the stakes of a user, then the balance of the contract in both tokens. And also we have the transfer ownership, which helps the owner to transfer ownership to oh my god, I just okay, which helps the owner to transfer ownership to uh, a new owner. So and the new owner comes and claims it. So yeah, that's it. So we're going to be testing this contract right now. We'll go to so the first thing I'm going to do, mine is already in auto. You come to this icon here, all right, and you click compile. But you can also put it in auto compile, alright? So you can say auto compile. So and just click compile. Now we will be testing the contract. So we want to test our contract. So the first thing we're going to this stuff about RMSS, it gives us this it allows us to test our contract. So it gives us dummy accounts and free it out to test our contract. So the first thing is we have our MPX, our stake, and our XY contract. Now we'll go to anytime you want to deploy, you have to click on any of the files so you can see them changing around here. Okay. So just for you to know. But now we want it to be our MPX. So come here, MPX token. Now, we'll be using the first account, all right? We'll be using the first account. So the first thing we're going to do is requesting for the owner so we'll say do this. We're going to paste the contract address there. I said we're going to paste the owner's address here, then transact. And we'll do the same for the X file. So about that, in the X file, we forgot to change the name here. So please remember to change the name to X file token. And we're going to also copy the address and put it. So transact. So we now have both our tokens, our token contracts. Okay. Then for the stake, we'll click that. Click the stake, and it's going to be requesting for the XY address and the MPX address. So we just copy them and paste them in their respective places. So for the XY, we paste it here, and for the MPX, we paste it here. Transact. So and for our XY token to be able to dish out rewards, we have to mint the rewards for it. So that's the XY token. So for our stake contract to be able to dish out rewards, we have to mint XY token to it. So we just copy the address and go to mint and paste it. Paste the mint. So you just do 10000. You can do as many zeros as you want, but you can do up to 25 zeros or more. So I'm just going to do as much as I can. So we have enough rewards in abundance. So paste. All right. So okay. Um, we'll be doing that, and we'll check the balance of this address. So the balance of this address. This is the balance. Now the thing is, we're going to. I know you guys. Some people will be confused about these zeros. So we are actually calculating the way amount in Ether. So let's say Ethereum unit converter. Okay, so it does have its own unit. So it has way, we have way. The others okay. So let's just copy this. We're doing everything in way. So let's copy it and put it here. So this shows you how many ethers we have. So this is like you got know how many ethers that is. Okay, so but one ether is 18 zeros. Okay, in way. All right. So just for you to know that. Now we can move on. We're going to do we're going to mint MPX for another user. So we're going to mint MPX for another user. Let's go get the user address. So you come to this place and select a new address, then copy it, then go back and click and select the address we were using before. So then paste the address here, and you can come to this unit converter. So we can be more accurate on what we want. So you can just mint 100 ethers for the person. So copy the way and paste it here, and we're good to go. Transact. Good. Now what else? What else? All right. So we've minted to this person. Now we're going to switch the account to the account we just minted to. All right, so which is the 0xAB. So since we minted that, now we want to approve the stake file contract to be able to help us spend our money. So we'll put that, and yeah, we just want to stake one. Should we stake 10? Okay, we just want to stake 10. We just want to stake 10. Are we good to go? We just want to stake 10. And we'll paste it here, then transact. So we've approved our contract to spend on behalf of this address. All right, we've approved the stake file contract to spend on behalf of this address. Now let's go and try staking and let's see if our this thing is going to work. So we can just paste the amount here. Then we'll just give it, let's say we'll give it like 10 seconds. So 10. Remember, we're doing it in seconds, right? So we just want 10 seconds, then transact. Oh wow, it's going well, it's going well. All right, so we now have our stake. So we want to check the amount of we want to check the stake info. We want to check the info of the stake by the user. So you just put 0, and yeah, you can see the information. So you can see we have how many ways. We have the stake, we have the timestamps, and then the as withdrawn bull, which is false at this time. So we're just going to talk about nothing and wait for 5 seconds. I think it should be done. Okay. All right. So let's try and withdraw. Okay, let me just do 1, 2, 3, 4, 5. Okay, I think that's 5 seconds already. Oh, it's 10 seconds. Oh, we can try it. Let's see if it's time to withdraw. So we just want to withdraw 0 and transact. Oh, and the withdrawal is successful. So we are done. and you can check again, which is true now. You understand? So we've withdrawn and everything is now set to zero and it's true. So I think the duration was met already, has been met already. So good. And we are good to go. So we'll be moving to that to deploy this on XFi. All right.